Okay, this one's example 7, and we've got two parabolas here. One is opening up because there's a positive sign in front of it. One is opening down because there's a negative sign. I would use my graphing calculator, plug this stuff in, equals 0, equals 28, and it will give you the two parabolas. And then you're going to have to look and see what part of the graph needs to be shaded. So the first thing I would do is set these both equal to y. So my top one would end up being y is less than or equal to 10x minus x squared. And then my bottom one would be y is greater than or equal to x squared minus 8x plus 28. And since y is in essence equal to that, 10x minus x squared, whenever I see a y here, I can replace it with 10x minus x squared. So that way I get all my variables the same in one equation. So I'm going to take all this junk, move it over here, and I end up with 2x squared minus 18x plus 28 equals 0. And I can use my handy-dandy factoring skills. Factor out a 2 first of all, and that leaves me with x squared minus 9x plus 14 equals 0. So that's what I'm going to factor into my two binomials there, where I have x minus 2 and x minus 7. Therefore, my x is 2, and it's also 7. And when I plug those in to find y, I find out that my y then, when x is 2, my y is 16. And when my x is 7, my y is 21. Okay? So that, in essence, is where my 2 points are, or where my graph crosses. So I'm going to get rid of all this junk and bring my graph over here. And I'm going to put down 216. So let's say that each of these numbers here represent 2, 4, 6, 8, 10, 12, 14, 16. Okay, so I go over 2 and up 16. So I have a point here, and I also have a point at 721. So 2, 4, 6, 7, 2, 4, 6, 8, 10, 12, 14, 16, 18. Ooh, that puts me way up there, doesn't it? Up around 2, 4, 6, 7, up around here. So I'm going to end up with, and I'm going to just kind of throw a graph on here that isn't going to be real accurate, but it's going to give you at least an idea of what it looks like. Something along that line. So those are my 2 points of intersection, and my answer then is going to have to do with being over here, greater than and less than. Okay, so my greater than is going to be greater than this graph. Let me get it over here. The red is my greater than graph. And then my less than would be my graph that was 10x minus x squared, which is this one. So what do they have in common? They have in common this information right there. Okay, that is what should be shaded. Okay, because less than would be below, greater than would be above, and that's where they meet. So any number in this little blue area here would make both this top equation or inequality work as well as this bottom inequality work. Okay, and that's what I'm looking for. The numbers for x and y that work for both of these. And how many numbers are in here? There's an infinite number of numbers in here, but they have to be within that blue spot there. All right, so I think this is the last one. Yeah, example number 8. So what we have here is, let me see if I can get rid of this stuff here without losing my graph. Okay, slide that over there. Talk to myself. All right, so they give us the system y is greater than x cubed minus 3x. They also tell us y is less than x, and x is greater than negative 2.5. And finally, they tell us that x is also smaller than 2.5. Okay, since we have these bottom two parts to the graph, those are just telling us kind of the boundaries, that x has to be a number less than 2.5. So I'm going to draw a line here at 2.5. Okay, so my x has to be a number less than that. I also know that it says x has to be greater than 2.5. So I know that my x value has to be somewhere in between here, which means no matter what my graph looks like, my answer has to be somewhere in here within these boundaries. It also says that y is less than x. Well, where y is equal to x looks like this. If I can draw it correctly. Okay, we're looking at a 45-degree angle here that goes through there. That's pretty close for y is equal to x, but it's saying anything less than x, so I know it's going to have to be below here if y has to be less than x. Okay, what else does it tell us? X cubed minus 3x. Okay, so we put that in our calculator to graph it, or we could graph it on our own by putting in points, and we end up with some graph that looks let's do this in green, that looks something like that. Because it's a cube function, it's going to have that kind of a shape. Alright, so now what I'm looking for is what numbers make all of that true. Well, I know because of this, it's going to have to be somewhere in here. It can't be out here or out here. And I know because y is less than x, it has to be somewhere in here. Okay? Well, now I've got this green graph here that I have to be a part of. So now I'm not only in this area, but I'm also dealing with this area as well. Okay, so I've got all of this here as a possibility, but this green thing is locking me in. So I start doing a whole bunch of different messing around with numbers and find out that my answer is going to lie somewhere in there. Okay, just because I end up putting numbers in there, and it helps me to make that discovery. Okay, so that is it for 8.1.